you see now that they're reinventing how people are going to be transported with robotaxis. So you want into robotaxi supply chain.
Because this AI6 chip is going to be able to be used for different types of things. So they put it in the robotaxi, they put it in the human or robot. They also use it for training, right? Because AI6 is something that is going to be used for training. Literally, at any point in time, Tesla can be like, run it at full because I'm gonna buy it.
I'm coming in and I'm the captain of 3 or 4 different major industries that are on these massive growth arcs.
He talked about how years ago Tesla had already started, and he said a long time ago they were already thinking, man, these robots sure are dumb. It would be nice if we could make them smarter.
Jeff Lutz, for those that follow Tesla very closely, he is a phenomenal resource, the GOAT, especially when it comes to supply chain, vast amounts of experience. And the reason why this discussion specifically is going to be very interesting is because, as you may well know, Tesla and Samsung struck a deal around chips, which is probably a much bigger supply chain play than a technology play, especially after we spoke with James Dama on the back end. There was also another one with LG Chem that came through that was for $4 billion. Correct me if I'm wrong, right around there. The Samsung deal was 16.5, and Elon's saying it's the beginning of potentially way more long term. So super high level, Jeff, just so the audience can catch up to where your brain filled with expertise is at. High level take, where are we at? And then we'll drill this sucker down.
Well, these are 2 great companies for Tesla to work with. I didn't see the confirmation from Tesla on the LG side. It sounds reasonable. The fact that they're only doing about 10 gigawatt hours of their own capacity, and they probably need 10 to 12 times that in the next couple of years between Megapack and eventually other products. It makes a lot of sense that they need to add capacity in that space, and LG is a good partner. And by the way, there's all these concerns, LG and battery fires, Porsche, Bolt. Remember, there's an integration step from battery materials to cells to packs where the OEM has tremendous amounts of accountability of how that's packaged and put together in the product and what are the safety standards and requirements and quality capability. And that's where Tesla excels. And maybe some of these other companies don't excel as much. So LG is a good partner. And I would put all that other stuff to the side. Tesla knows how to make cells. Tesla knows how to construct packs, design packs that don't have any issues like this. So yeah, this is if you're the supplier in these situations, you look at a leader like Elon, you look at a company like Tesla, and you see where they're going. You see the arc they created in the EV industry, and you see now that they're reinventing how people are going to be transported with robotaxis. So you want into robotaxi supply chain. Anybody else that's making a robotaxi they're at much smaller volume phases. They may be at a proof of concept phase. They may never enter into what you would call real high volume production. There isn't anything out there in high volume production today until you get to a Tesla Model Y that can be built every 30 seconds. There's nothing like it. It's several orders of magnitude different. So if you're these suppliers and you're looking at, okay, Tesla created this arc in EV. They're not done in EV, by the way. There's definitely a stall in the growth of conventional manual driven cars. But then now that they've got this FSD deployment, they've got robotaxi deployment, and now they're ramping up on the data center side. They are creating the AI factory that's going to power their own factories and their own products, right? And so Dojo is going to go from 8 to 10% of the training load to maybe, who knows? Hans, you're following this. It could be 50% higher next year, could be double next year. But now this purpose-built AI6 system is complete inference system that can, at that point in time in 2026, 2027, we'll be going into humanoids, we'll be going into vehicles and robotaxis of all kinds, and of course into the data center itself. So if you're in the supplier's shoes and you're looking at Tesla, you're looking at Elon's leadership, you want to work with people that know how to create product, create industry, and manage their supply chain. And if I were to just break all that down, there's a lot of companies that are building stuff. There's a lot of companies with great brand names, but then they fall apart in managing the supply chain. They've got 200 weeks of inventory, or you want, or they say they're going to build, a data center the size of whatever, a certain city, and it takes them 3 years where it takes XAI or Tesla 3 months or less. And so if you're going to partner with somebody, you want the inventory pulled, you want you want certainty in the transaction, and you want to see that arc of growth. And I think Tesla and Elon companies provide that.
Yeah, Jeff, can you just, for the audience, elaborate on why, if you're a supplier, why does it matter to you if your customer is good at pulling inventory?
Yeah, you want, if they're turning the inventory quickly, then you're getting paid quickly, and therefore you can pay your suppliers quickly, and the whole flywheel is turning. And if you set up your cash conversion cycle correctly, you could be generating cash off of this deal. If your customer cannot build data centers quickly enough, cannot sell cars, then they're not going to reorder. And then now you're going to have this lack of predictability in your own supply chain, and your own supply chain is going to slow down. The fuel for supply chains are speed and reduction of nodes and network latency. It's all about speed. And if you have that and you have that certainty, then it's if you don't have that, this is where you have major economic breakdowns. If you go to Samsung, right, they were stalling and stumbling a bit to get a customer assigned to this fab. They're not the number one maker of sub 4 nanometer node tech in terms of yield and process times. But the unique relationship here, I think some people have this a little bit wrong. They think Tesla employees are going to be running around managing production in bunny suits. That's not the situation I would envision. The situation I would envision is a very, very close working relationship between Tesla engineering, design, and the manufacturing design teams, the fab teams from Samsung, so they can make a very high yielding chip that uses the minimal amount of material and the minimal amount of process time and the minimal amount of scrap. And when you do that, because I think what Elon's seeing is in 3 to 5 years from now, there's going to be a bottleneck here created. And the only way to get in front of that bottleneck is to control your own destiny. So Tesla doesn't need to own a wafer fab. They don't need to do that. But what they can do is they could partner with somebody who has tremendous capability. And quite frankly, the culture, the Samsung culture is unbelievable from a work perspective. I had a team in Korea for over a decade. Some of the most amazing people you'll ever meet in terms of work ethic and so forth. So anyway, it's a great partnership. But Tesla is going to really blend the product development efforts so they get something into production, very high yielding, very low process times. That's what they're looking for with this closer and closer partnership. And quite frankly, they essentially own and can prioritize this fab. So it's a very good relationship. $16.5 billion is just the beginning. It's really Tesla putting their place in line, saying we're a serious player, and I'm sure that money plays out over time and certain milestones on both sides.
And Jeff, how do you translate or interpret Elon's claim that they're going to be that the Taylor, Texas factory is going to be dedicated to Tesla? Does that mean that Tesla is the number one customer and gets number one priority on everything, but there will be other customers? Or is that like 100% of production out of Taylor, Texas is allocated to Tesla?
If you're Tesla and you're Elon, as long as you can keep that fab up and running 70, 80% utilization, then you want first right of refusal to own it and prioritize it. Which versions of AI6 are they running? Are there certain ones that have certain characteristics and quality that can go for inference? Are there certain ones that have to go in the data center? You could have other customers in the fab, but you ultimately want priority of what wafers are being started, what's the schedule, what's the process time, what are people working on, and as long as you can fill it up, then there's a huge benefit of you having that. But if you can't keep it full, if you have uncertainty in your demand, and I think this is where if you're a supplier, Tesla and Elon are such an interesting it's such an interesting partner, because when you sell to him, you could be, again, selling for a data center application. You could be selling for a vehicle robotaxi situation. You could be selling for Optimus. I mean, there's no one other. When you have that kind of redundancy as a customer, you now become more valuable to your supplier, and you can actually create the kind of deal that other companies cannot. You can't just come. I mean, there's companies that have tremendous amounts of cash and can go in and they could reserve a fab. They could totally do it. But in terms of the terms of that deal, when you have the kind of portfolio that Tesla has and you have the visionary CEO, you can probably get the kind of deal that others just cannot.
Let me see if I got this right. So Tesla, because this AI6 chip is going to be able to be used for different types of things. So they put it in the robotaxi, they put it in the human or robot. They also use it for training, right? Because AI6 is something that is going to be used for training. Literally, at any point in time, Tesla can be like, run it at full because I'm going to buy it. I might not have enough robots, human robots, but I have enough cars. I may not have enough cars and robots, but I have a training cluster, right? And so it doesn't matter what kind of, or, who knows, drones down the road or whatever new thing they come out with. There's always going to be a place for them to put this chip. And so the deal is going to be just go as fast as you can. We will buy it from you. Is that a good representation of what you just said?
Yes, and each one of those industries are parts of massively growing arcs. So it's not a dying industry. It's not a single industry. I'm coming in and I'm the captain of 3 or 4 different major industries that are on these massive growth arcs. Well, I mean, there had to have been like a run for the door in terms of trying to get this business. I think it's really smart of Tesla also to have the geographic redundancy between Taiwan, Korea, and the US, and to have the supplier redundancy between TSMC and Samsung. I think it's very smart. This is very, very smart supply chain management, but this is enterprise risk kind of level stuff if it's not done well. So it's really, really well the deal. I'm sure that, Tesla's supply chain does not get the kind of notoriety. They're just in the background getting, what done. But I mean, this would have been, Karn, the VP of supply chain, pulling this together, and his team, obviously with Elon's guidance and leadership. I mean, this had to have been like one heck of a deal. And again, Tesla has tremendous leverage. Elon companies have tremendous leverage. And yeah, you nailed it. It's that redundancy. That's value. That's terms that is terms in the negotiation. And if you're Samsung, all you're thinking of, can I have a highly utilized fab? Well, if I have this customer with this amount of this amount of redundancy in what they're building, then I feel good about it.
Thank you to the sponsor of this podcast, Rebellion Air. Now, we know a lot of you are Tesla fans, and especially Tesla investors. And if you have more than $1 million of Tesla stock, Rebellion Air could be the perfect fit for you. Rebellion Air is an investment firm that helps Tesla investors reach their financial goals. They do this by helping you plan for your future, and they also institute strategies like trimming and adding, covered calls, etc. So if you're somebody who believes that Tesla has long-term potential, these kinds of strategies could maximize the number of shares you have by the time Tesla reaches those goals. And the guys at Rebellion Air do this by doing so much research research on the Tesla story, and they do a lot of novel research as well. Things like doing cross-country full self-driving trips to really gauge and truly understand the capability of that specific software. They've done really novel research around the energy side of the business and other parts of the business as well. And so instead of dealing with a typical investment firm that may give you the cold shoulder by viewing your investment as too risky, the guys at Rebellionaire will help you reach your goals while fully understanding the Tesla story. And so if you're a Tesla investor and you have more than $1 million of shares, and you're interested in finding out more about Rebellionaire, I have a link for you in the description in the comment section below. You can go to rebellionaire.com/Farzad, and that's how they'll know that we sent you. And now back to the podcast. So was there something about this deal, I may have missed this, is Samsung the exclusive fab, or can Tesla also partner with TSMC for AI6 onward?
Tesla can do whatever they want. I mean, if Samsung can't make the part from a process yield perspective, time perspective, if Tesla can do whatever they want. In my opinion, there's no. There could be some exclusive. We don't see it. We're obviously not going to see the contract. We don't know if there's exclusivity behind it or not. But even if there was exclusivity, if Samsung was not for some reason executing, Tesla should have a clause to be able to break something like that. But we won't see that contract ever. There may be terms of it that come out at some point, but we just know location, we know process node, we know, the version of chip, and we in a perfect world, we should not know much more.
Got it. One of the analogies I like to think through, and you tell me if this is a good way of thinking about it. So Apple, way back in the day, they decided to go with Apple Silicon, right? They decided to basically design their own chipset and optimize their software to the hardware so that you had this incredible experience. And then for the longest time, that was their competitive advantage, was that, it just works. Remember the whole it just works? Well, that was the marriage of software and hardware. Is that a good way of thinking about what Tesla's doing here with AI6, with Samsung, and a partner with somebody that will allow them to marry AI software with AI hardware?
Well, Tesla's had this since they've done their own computer. So since they created their own silicon team. Remember, this is the AI computer. This isn't the infotainment computer. Yeah. Since they've created that team, they've had this thing. They've had this ability where you're doing hardware design for the chip, and then you're running the operating system to utilize that chip inside of your company, and then you have system software that's on the vehicle in this case, and all of that whole team can walk from one end of the building to the other and communicate and work together, so they get the lowest latency, they get the best performance, they get the most per square millimeter out of this silicon, and that is part of Tesla's advantage in this whole thing. It gets completely overlooked by analysts, but this is how you're getting the type of performance with computer vision, and maybe $1,000 or $1,200 total system for self-driving. I'm estimating something in that area, maybe even less, and that's how you're getting it. And the other ones are an order of magnitude higher, times 3 or 4, to deliver the same. Not even deliver the same solution. So yeah, it's vertically integrating the engineering on silicon, especially as it relates to now AI inference and how important this was. This was seen 10 years ago by Elon and the team at Tesla. This is going to turn out to be one of the greatest moves for the company. As Elon says, he can't buy per dollar per square millimeter of AI4 silicon. He can't buy anything better than what he has.
So Tesla is Apple, NVIDIA is Android. Is there a good way of thinking about this for the layman?
No. No, it goes much. I think it goes a bit deeper. I think it can go a bit deeper. It's close. The Tesla Apple relationship is close. They both developed their own, call it CPU silicon. It's pretty close. I would say it's a pretty close comparison to Apple. NVIDIA, though, is I would say it's more than Android. I would say it's more than Android because there's a huge hardware component to what NVIDIA provides. And Android runs agnostic of most. I mean, there's requirements for it to run, but Android's more agnostic. The NVIDIA hardware solution is unbeatable at this point in time. Like there isn't a Dojo equivalent to what Blackwell and Blackwell Ultra is today. And as NVIDIA transitioned to Blackwell, they actually took on more and more of the system, and they've improved the performance of it, and they've actually reduced the cost structure of it along the way. So nobody's catching NVIDIA in this generation, and you see a lot of people have tried and they're kind of dying, doing it. Nobody's catching them in this generation, but within a couple of years, there'll be more and more capability. I think that obviously you see what Tesla's taking on with the train load.
Let's go for it.
Yeah, I'm kind of at a loss for where to take there's so many different directions we could go from here, but maybe zooming back out to the high level on what are the major benefits to Tesla of working with Samsung from your point of view, that we haven't really touched on. I mean, obviously there's the big one was supply chain diversification, that you get, you're locking in an incredible fab. You don't have to put up the CapEx to build the fab. It's almost like you built it, and you have access to it. Like you get to go and be in location. I don't know that they would have gotten that with TSMC. And then, your supply chain is not dependent on TSMC and it's not dependent on China. So those are great benefits. Is there, anything else that's really major and significant in this?
Well, it is a special relationship. So if you're walking into TSMC, remember, in terms of total volume of silicon and who's buying stuff from them, it's NVIDIA and Apple, and AMD's way up there too. Tesla wouldn't be the number one buyer of product. And therefore, when you're not number one and you're walking in and you're trying to get resources on their side, you're trying to get fab allocation time, all of these things matter. And when you're number one, you get all of that. You get the best resources that are available in that area, and you get the allocation time. If you need to, if the line needs to be taken down, there needs to be some sort of modification. Instead of them trying to jam someone else's business in, and then you work on your problem and everything is about your part. And so they're going to have priority. They're going to have the best available team. I would hope that they're getting the best available team in the world, quite frankly, but certainly the best available team that Samsung has in the US to do this work. So you're getting that 8 week in the industry. We called it like, am I getting the A team or not? Because if you have A team level business, like if you're the top, you're going to get the A team at that. And it makes a meaningful difference. If you don't get the A team, if you get the B team or the C team, then it could set you back, whether you're not getting to market as quickly, you have, worse quality, or you have a cost issue. If you can get to me, the big value is you get the A team, you get priority all the time.
Yeah, I think that's one of the things that people miss, is that just because TSMC might be, they might have 2 nanometer working better, faster, higher yields than Samsung, that doesn't mean that Tesla has access to that working 2 nanometer node within a reasonable time frame. Like even if Samsung is 6 months or a year behind, but Tesla's the number one in queue for that, then they're probably still ahead of where they would be if they were working with TSMC. How do you see the CHIPS Act really playing into this as well? Like, is there going to be a meaningful tailwind for, both Samsung and Tesla coming from that?
Yeah, I think a couple of things. So your comment, I do think that Samsung and Tesla are going to converge on something for AI6 where they want to be, best in class for yield and process time. So it's going to be one of those things where it's 2025. We're not there today, nor are we taping this chip out anyway. But, if it comes, late next year, maybe this thing goes to tape out, or the early the year after, we would want, between now and then, let's figure it out together, how we get the best process times, the best yields in the world. In terms of the CHIPS Act, I liked it was one of my more favorite things I thought of the last administration, but it didn't go far enough. So, for example, we're going to go 2 years now, 2024 and 2025 now, with that TSMC Arizona fab running with no packaging nearby. So if AMD's making parts there, or Apple's making parts there, the parts go to Taiwan or Korea for final packaging and test, and then they go back to it, then to a factory wherever in APAC, or maybe back here. I mean, depending on whose product it is. What I think is going to be different in this situation, both for TSMC and Samsung, is in 2026, you're going to now start seeing the AI computer being fabricated in the United States, and you're going to see it go into a final product assembly in the United States. And I think that's where a lot of this magic starts happening. This is where you start taking out the supply chain latency. This is where you really start. This is where the CHIPS Act didn't go far enough, which was, okay, I'm going to make silicon here, but okay, I got to package it. And then I need to figure out the rest of the supply. What are the terms? How do I get people to move final assembly to the US and where it makes sense economically? That's where I wish the CHIPS Act turned into an Assembly Act.
So is there anything fundamental that the government has to do from a regulations or incentive perspective to start moving that here? Or is it going to be just a forcing function of demand for these products will help us resolve that? Like how
the government, yeah, it's a good question. The government is putting the forcing function with tariffs and the Section 232 tariffs. I mean, right now we're on a pause. So semiconductors aren't being tariffed. Semiconductor derivative products aren't being tariffed. Even if you see if you see 30% out of China, those products are carved out. Or if you even see the Taiwan reciprocal tariff hasn't been announced. So I think they are going to incentivize semiconductor movement to the U.S. The question is, how do you do it in a way where you're not killing your own captains of industry back here who are trying to build stuff, but you keep tariffing the inputs, which is happening right now. So that's what the government thinks they can do, which is tariff to bring this stuff back. The packaging facilities have been kicked off. They're happening. They're just the one in Arizona, I think, is going to be probably from Amcor will be online in the first half of 2026. It's just weird that it wasn't. You can build a packaging facility much quicker than you can build a wafer fab. I don't know why it wasn't up and running, a year ago. So these are the kind of things. But the government is definitely incentivizing silicon manufacturing in the U.S. This administration thinks they're going to get there through tariffs. The prior administration thinks investing, $43 billion is going to get there. But these are companies with incredible capital structures. So you have to wonder, why are we? The government needs to take permitting time down, needs to take regulations down. These companies have the money to build these fabs. Now, at the same time, we have to be competitive with what APAC and China and others are doing to incentivize this. But it's happening.
On this Taylor, Texas plant for Samsung, do we know anything about whether packaging will occur there or nearby? Is there any details that you're aware of yet?
I don't have the details in front of me, but I would be 100% certain that it would be fab and packaging on site.
And just to be clear, when we say packaging, we mean the actual packaging of the chip itself, not boxes, right? I just want to make sure we're clear about
Correct.
that. Okay.
This is think of it. This is it. The singulation from the wafer, and then does it go into a chip on wafer on substrate? Does it go on to some other configuration? There's many different configurations. You would package the chip differently for a data center application than you would package it for building it into the computer for the car. But the packaging we're referring to is not boxes and manuals and paper. We're actually talking about how the actual form factor of the chip, and then how it's actually mounted into a system. And then from there, then Tesla has to build in the Tesla case, they have to build the computer. Now, I'm not certain on this, but I know at least recently the the AI computers were assembled in Mexico and Taiwan. You can look at them. You can pull one out of the car and you can look at the assembled in sticker and you can see that. So it would make sense. And Tesla may have already done this because I think it's pretty easy. It would be to move the actual PCBA assembly and then the mechanical assembly and test into the actual AI computer that goes into the Tesla, move that stateside as well. There's no reason. Yeah, SpaceX with Starlink, they've already demonstrated this capability of PCBA assembly, mechanical assembly, and test very well. I think that what I've seen of that factory is the model for, to me, how we should be doing more and more smaller device electronic assembly in the US. That factory is resin, bags of resin coming in, metal coming in, and Starlink dishes coming out the other side. And I think it's very well done what they've done there.
Probably Elon's closest thing to an alien dreadnought factory so far.
Yeah, I think the auto factories are the robotics in auto factories are the robotics needed to do some of these smaller electronics are actually less impressive. There's more precision in some of these situations, but a lot of that robotics has been around for a bit of time. So like surface mount manufacturing of PCBAs, that's been around for a long time. And so like bringing that to the US to me is a no-brainer. And it's, very little labor involved. So anyway, I think it's a model for what you're going to see other AI type devices being produced.
I actually want to drill down on that stateside discussion. Is that okay, Hans, or did you want to take this? Okay. So, when I first heard this announcement, and I know we touched on it a little bit earlier in the pod, but to me, this was such a smart move. Thinking about the volume projections that Tesla has from a product perspective, just the sheer number of units that are going to be out there for robotaxis and especially humanoid robots in the next 5 to 10 years, especially in the next 10 years, that is going to be tens of millions of chips per year, at least, that is going to go into each product, right? And then to me, the Taiwan risk factor that has existed with TSMC, it seems like there's finally some movement to try and diversify, not just Tesla. We touched on this a little bit briefly, but it seems like there's an overarching trend, like a trend that is almost forcing people to localize a lot of manufacturing and localize a lot of supply chain. So can you maybe drill a little bit down more on why this being built in Taylor, specifically in Texas, United States, why that's such a big deal and why it's part of a larger trend and what are some of the benefits?
Yeah, I mean, supply chains have been quote unquote globalized, starting in the 90s, and people don't realize that in the late 90s and early 2000s, there was a fair amount of electronics assembly still done in the US. I was a part of that and in leading, and then there was this big, huge movement where you had more localized supply chains back then, but there was a clear movement towards globalization because there was more complexity coming into these products and the cost structure was ballooning. And then you had this lure of China of, well, hey, your $10+ an hour labor rates there, they're 5 times, 6 times cheaper to do it here or more. Move it here, and we'll send the product back over on ships, and the cost structure is going to be amazing when you do that. And that lure worked. In terms of the value, and now we're going back in the other direction, right? So you have this tariff regime that's out there, which, again, this could be its own show, but we'll put that to the side for now. And you have geopolitical tension. Some of it could be kinetic in nature, but there's just nonstop tension that's happening. You have boats being rerouted. You've got you name it. And so you have that happening. You have the economic burden of the tariffs. And what it's really driving is this, and COVID was the wake up call of like, hey, there's certain things we need and we can't even get it. Can't even make it here if we wanted. And I think that was, medical, pharmaceutical, electronic. Again, if a certain country was seized or we went to war with another country, we would imagine not having the ability to have a phone. So I think there was a wake up call with COVID. I don't think a whole lot was done legislatively, to be honest with you. Defense Production Act here or there, but I think with the tariff regime, the continuing geopolitical tensions, it's now ratcheted up to a level where you're seeing real activity happen across all industries, and some are getting more and more shocked. And some are flat-footed. Some have been on top of this for a while. Tesla has been localizing their supply chain for the last 10 years. They have been. Now, there are instances, and even in the last 5 years, of Tesla creating global supply chain suppliers where they may have been developed in China, serving the Shanghai factory, and then their path to fame would be is like, okay, if you do a really good job here, we'll just ship your parts to Berlin. We'll ship them to the U.S. Tesla was doing that as well. But and this is why you had 70 and 80% localized supply chains in the U.S. You didn't have 90, 95, which is meaningfully different in that situation. So getting back to your question of what does this mean in Texas, these are going to be the first examples of, I think, a trend where the AI computer and the final device that's in consumers' hands or consumers' drive-in will have that the network latency between those things are going to be minutes and hours, and not going to be this comes from over there and this comes from over there. And if something happens, I have no computer. Look what happened with automobile production in COVID, and it wasn't even necessarily CPUs. It was the easiest popcorn switch parts and other things that were 10, 15, 30 nanometer parts that we couldn't get supply of. So it's really about security of supply. It's about reducing network latency. When you reduce network latency, then if you have shifts in movement of your inventory, of your demand, you don't have this very long amount of time between you and where that part is made to go in and correct it. You can correct it faster. And when you can correct things faster, and when there's less time between those 2 points and those decisions, you have less inventory, you have more cash available.
Don't have anything to add there on that point.
It's
just really cool to see, that we are starting to reindustrialize, I guess, and that Elon has been leading the way. Like Jeff said earlier, the Starlink factory that's there in Bastrop is already a big deal. The level of scale that they've been able to reach is huge, and it really proves like it's one of those things that goes out there and it shows, yes, we can actually manufacture electronic components from soup to nuts here in the United States at low cost, high quality, high scale, all of those things. And they just continue to up the ante every quarter. It seems like they're shipping more and more. They're continuing to refine the product. So like the product's evolving as they're reaching higher and higher levels of scale. And so I think that's incredibly important to put out there. And I hear a lot of people who are movers and shakers who are thinking about the types of challenges that we do face with, national security, globalization, deglobalization, who look at that example and they think, wow, if Starlink can do that, we can actually do that, and we can do it across more things. And to allow Elon now to start leading that charge here on the AI chips themselves with Samsung in Taylor, Texas, I think it is a big deal.
Yeah, it is very achievable. This is something that has been misconstrued by the media, been distorted by the media, by people in the financial community. It is not thousands of dollars to be able to manufacture electronics in the US, you have to know what you're doing. You have to know how to develop your product, how to develop the supply chain around your product, and you have to understand those core metrics and what's important. And when you do, you would build it up the right way, just like Tesla did with Starlink, and you would have an economic model that works. Where the economic model gets distorted is when either you have the owner of the company, the product, the operation that doesn't understand how to do it, or you have these existential things happen, these inputs being that come out of nowhere. If copper is going to be 50% more, aluminum is going to be we don't have the capacity to fulfill all of our needs for copper. We can do about 45% of our demand in the US. And so for the 55% of it, we have to spend 50% more on top of the import costs and on top of whatever duties. By the way, we're not going to get a great deal abroad if they know that we're capacity constrained in the US. We're not going to get a great deal abroad. So those are the kind of things that could actually be disruptive, more disruptive than helpful in USA manufacturing. So I hope this gets worked out, call it over the next couple of months, where if we target things that we're going to build, that we don't necessarily destroy the input cost structure to do it. Because if that's a level playing field, then we can build whatever you want here. And yeah, there's going to be some variation, but this is where companies need to figure out what they have to automate, what they have to change. And then at some point, the advent of humanoids comes in the future, and then this whole thing gets disrupted again. But you don't have to wait to humanoids. You can build anything, quite frankly, that's built in Asia. You can build it here. You just have to build the right plan for how to do it.
Like drones, right?
Yes. I want to be very clear. There are significant supply chain deficiencies in the US. So I think you have to start with an assembly model in the US, and then you have to work your way backwards over time. If you try to do everything at once, where you're basically inventing processes and supply chains here all at the same time, well, then your probability of failure is greater. You have to look at these things over a time arc. So if our time arc is we want the ability and unlimited supply of drones in the US for defense, industrial, and consumer use, then we're not going to have a 1-year time arc. We have to have a multi-year time arc. But there's no reason why in 2 years we couldn't be assembling all of our drones here and then working backwards in that supply chain.
It seems, and I know Hans sort of touched on this before we went live on the drone subject, but I've been on this sort of train of, given now that there's this overarching trend of bringing manufacturing and supply chains and making them more localized to the country where those products are going to be sold in, at least in the countries that have enough labor available and enough raw materials, as many as possible, to make those things. It seems like Tesla specifically is very well positioned to get into the drone game, because the propulsion of a drone is going to be battery based, and so Tesla has the battery supply chain. The navigation is going to be in 3D space using artificial intelligence, which is something Tesla's very good at. And then anything they need from an avionics perspective, oh my goodness, SpaceX seems to be like the perfect person or the company to talk to. So how much, and then Hans made a comment earlier too. I don't know, I can't remember if we were recording or not, but he said, one of the things could be that the Samsung partnership could get Tesla into the drone game. And you made a comment where you said that they don't need Samsung to get into drones, right? So help us understand that better.
Well, I'm sure they could be helpful on the battery side, but in general, you wouldn't need them. What you would need is, you're right. Tesla and SpaceX have these assets, and it's a hybrid of them. So if you think about the drone body, for example, if you're going to do a larger industrial drone, then you're thinking of more metallic features and metallic substrates. If you're thinking about smaller consumer drones, then you're thinking of plastic injection mold composites and the things that you see in a Starlink antenna, for example. So Tesla and SpaceX have these assets. They're not all in one group. It's kind of a hybrid across. Like you don't see Tesla doing small molding, small objects per se. They're more working on larger electromechanical interfaces. But yeah, you're right. The assets exist. It really comes down to the electric motors powering them, the body engineering, the body mechanics, but there are other components. You start getting into micron level accuracy that's needed for these things, but it's not rocket science. Even Tesla, SpaceX have rocket science, but it's not even that. So it's totally doable. The question is does Tesla have the, or does the Elon companies, do they have the overarching business plan of why are we doing this and how is it going to be immensely successful, and what new category are we going to serve that isn't being served today because these drones don't exist or made in the US?
That's a very good point. That's the one thing I've been trying to rack my brain on for the last couple of weeks. What are some of these? So if the drone conversation is like, okay, the TAM for it doesn't make any sense for us. It's not game changing enough, right? There's enough players out there. It doesn't seem like there's too much additional innovation we can do on it. Could we dominate the US market? Sure. But is that really the best use of our time in factory space? Are there
the defense
any,
side is.
Yeah,
the defense side is for, the
true.
TAM there could be
ridiculous.
There's a predecessor decision there needed, which is, are you doing war with drones more in more of the spotlight or not? And if the answer is yes, and U.S. makes a tactical decision of how they're going to do defense, well, then there's a massive industry. But now you're serving the defense industry.
And I think Elon has made a comment in the past where he would rather stay away from the war industry. I think he may have made that comment because I know Starlink technically is being used in wartime, but it's not really designed for wartime. It's just, the U.S. government has found it so useful that they've trained to,
Yeah.
Yep. The reason that I think it's going to be hard for Elon not to do something with drones, it doesn't necessarily have to be huge and completely game changing. And I guess maybe, it is possible that someone else could solve this problem, but I do anticipate that there's going to be drones on Mars as we settle, that you don't want only terrestrial or earthbound surface vehicles on Mars. You're going to want aerial things as well. So, but yeah, that can, those platforms, if they're not high volume, could be supplied by other companies.
Have you come across any conversations around, you probably can't even talk about too much about anyway. What are some form factors that we're not thinking about at all that are being enabled by these technologies, specifically artificial intelligence in the physical world, that could be coming down the pike? Have you heard anything at all that you can divulge? Or you could say yes, but I'm not going to tell you.
Yeah. I think there are devices that you use today that will be more and more intelligent themselves, right? There could be very small amounts of inference power needed to make localized decisions. That could happen. I think the humanoid space is getting crazy. I think it's going to be similar to what we saw in EV, which there were so many people entering. The rate of entrance and then the rate of destruction of their company, you're going to see this. Now what's happening in EV is there's actually more China companies that are actually dissolving and blowing up than the new ones are being added. And I think we'll be in a similar curve at some point with humanoids, because there's very few companies that actually know how to make a product end to end that's useful at scale. And there's very few that are doing the hard work. There's a lot of them that are doing the work, and they're trying to drive investment, they're trying to drive a bunch of other things, but there's going to be very few. I think it's not going to be a winner take all, by the way, situation.
It seems winner take all to me. So help me understand that, because to me it's like, if you have a human or robot, so like let's play pretend and say Tesla gets to the highest scale. They have the biggest brain. How do you compete with that?
Well, yeah, if they have the highest
Does every
scale,
government in the world accept Tesla robots?
Oh, sure. Okay.
Yeah. So I think humanoids are going to be a geopolitical thing.
Yeah.
Because of the GDP implications, because of the defense implications as well. So I think unlike other industries where they kind of started and they could have been built anywhere, like mobile phones, for example, they're built everywhere, all over the world. Mobile phones are built. I think as it relates to humanoids, there's going to be a very, very localized. And by the way, I think this is driving a lot of the delays out there, which is who's making the actuators, and first off, who can make one at the precision levels that we need, and then can we set up a localized supply chain for it, and are they not of certain entity? So I think that will be a defining factor, but it'll just be for a period of time. It's not going to be a permanent defining factor per se, but that will be a defining factor in scale for sure. For
to
some
me,
period
it
of
seems
time, which is like, where can you sell it?
Yeah, to me, it seems like the actuator question is as big of a deal as the chip question. Now that you mention it, it's like that is the mechanism that's going to, actually manifest your brain in the real world. If you don't have an actuator system that is powerful enough or efficient enough to execute on what the brain can do, then your humanoid's not nearly as useful as it could be. So it's kind of like having Michael Jordan's brain but not having his body, or vice versa, or having Michael Jordan's body but not having his brain. Michael Jordan's Michael Jordan because you have the brain and the body together, right? Do you view it in the same way?
Yes. And that is the question that's out there. That's the level of detail that the YouTube videos haven't gotten into yet, which will be levels of dexterity. And then how long do these things last? How long do you get, the millimeter type precision and eventually sub-millimeter type precision for how long? What is the gauge R&R, which is a measure of repeatability and reproducibility of a particular system? Hans nodding his head. What is the gauge R? What are the, when we do any kind of automation in the factory, we are measuring the repeatability and reproducibility of that automation. And if it's not good, then it could totally screw up your cost structure. So what's the repeatability? First off, we're trying to answer the question of what level of capability and dexterity are these things going to have? And then once you answer that question of like, what can they do a sample size of one of? Then the next question is how long can they do it for, and for what level of precision can they do it? And all these things are happening right now under the surface. This is the ugly sausage making part of developing a product that you won't see out there. These are the alpha and beta stages and prototype stages where companies start something, go down a path, say, no, I gotta scrap it. I gotta do something different. So these are the things that need to be solved that you won't see in a few minute YouTube video. And by the way, then you get the power consumption. So once you electromechanically solve for the problem, are those electromechanics moving? Do they have power consumption that's representative of what's needed? Or is that equation, this was in the early days of smartphone, you'd had phones that would last 6 hours and phones that would last, 30 hours. And there were major differences in power consumption and how that was being managed. And then more and more of that started getting solved actually by the silicon vendors. And then eventually, of course, the OEMs themselves. So there's so many problems that need to be solved that are actually not readily visible to consumers today. I've written a little bit about it.
Yeah, and there may be a video about it as well. Actually, we'll see. Teaser. Go ahead, Hans.
Yeah. I mean, one quick way for Tesla investors to think about this is, Maxwell did bench scale, like prototyping, proof of concept of dry battery electrode technology a long time ago. Obviously, that's why Tesla bought them, but it's taken Tesla, all these years since that acquisition just to get to the point where we're at now, and we still are not fully ramped up on doing both cathode and anode dry battery electrode. And the reason is because all the types of challenges that Jeff is talking about, that these engineering challenges, when it's one thing to make it at the bench scale, if you can get one that works out of 10 that you try, hey, you won. Like, that's success. When you're in production, if you have one successful part out of 10, you're out of business. And so you have to figure out how to make 10 out of 10 perfect every time. And now, okay, you want to do 10 out of 10 perfect, and you need to do it 1,000,000 times faster than what you're doing right now. You can't ever fall below getting 10 out of 10 perfect as you speed up to 1,000,000 times faster. And those challenges, they just, they're exponential challenges. It's like the March of Nines for, a whole set of really, really hard engineering processes.
And I think when you bring this back to Tesla, I think they have developed their own operating system for manufacturing products. And
Jeff, let me interrupt you there for just a second. Quickly, did you hear Steve Jurvetson's comment from the X takeover? So this is an interesting tidbit for any of the audience that hasn't heard this. I highly recommend going and checking out his talk. But he talked about how years ago Tesla had already started, they're all using obviously these big one-arm robot things in the automotive manufacturing plants that do a lot of the work to make the cars. And he said a long time ago they were already thinking, man, these robots sure are dumb. It would be nice if we could make them smarter. And they were instrumenting them with cameras and hooking them up to their earlier versions of AI. And so it was just a throwaway offhand comment that he made. But if they were doing this, quite a while ago, building on, the same building blocks that they know that they have now turned into hardware for in the car, you can imagine what they have done with those robots since then, using AI, using vision, and trying to get a lot more intelligent.
Yeah, I mean, this is where this is going, but and that will, I mean, there are companies that are just they're not even in the same solar system, the same universe as in those conversations. I was even referring to just their operating system for how they manage supply chains, very low latency, very low inventory, how they manage factories, right? What's the automation framework? What's the decision around, should this part even, is the requirement right? Is the requirement stupid? Should the part even exist? If the part exists, should the part be combined with another part? Should it be simplified further? And then how do you improve the process yield, the process time, and so forth? And then you make a decision. Like, they have their own OS for how they think through things, and then everybody in the company thinks that way. And then now you're taking this to you have AI entering the factory, starting from the back end of the factory with cars driving out of the factory, to that's just going to continue moving its way further inside of the factory. That's where that is going. And there's just nothing close to it. I would say before Tesla, and there's other examples of really great manufacturing, but Six Sigma development in the 80s and 90s with Motorola. That was our operating system when we would talk to each other about product design and manufacturing. It was, can we get this down to under 3 defects per million? And we thought in that kind of framework. We had a framework to how to think about problems, how to solve problems, and how to use data and statistics. If you did not come into a meeting armed with data and statistics and an approach to solve the problem, you shouldn't really be there, because no one's going to listen to you. And that is a culture that has to be created. So when you come full circle and you start talking about, how do you bring manufacturing back to the U.S., you have to create the culture. That you have to create the operating system. And then from that operating system, then maybe you can automate it. Maybe you can put an AI wrapper around it, and then you have something to really build upon. But without that leadership to do that, this is where you're going to have a lot of things that are starting and stopping, or people not taking control when they should be taking control. And that's where you're going to have, but when you come full circle, this is that you're watching the playbook real time of how this is being done with Tesla and Elon and his teams.
Do you think localization is going to be a forcing function to vertically integrate stuff? Everything's going to be so close together. It's like, why not just put it in the same freaking building?
It is certainly possible, but vertical integration takes an incredible amount of time to build up. Like Tesla wasn't vertically integrated when Tesla incorporated, right? Everything was coming from abroad. You have to build that up over a long period of time, which is why the moat is so large with Tesla, because other companies, remember, they're engineering vertically integrated. And once you're engineering vertically integrated, then you can create the supply chain manufacturing processes and the relationships around it to do that on the supply chain side. But you have to start of like, I am doing system software inside of my company, and I'm doing component level software inside of my company. I am not going to go to Bosch to buy, motors, the seat movement software for my seats. I'm not going to Bosch for. I'm going to do that inside of my company, and I'm going to architect this whole system inside of my company. And these are decisions. These things take over a decade to do. That's why the moat is so large. So yes, it can drive more vertical integration, but it's not going to be an overnight thing.
I just like the imagery I can't get out of my head, and this might be like, I mean, this is definitely way too naive and just way too oversimplified. But in a couple of years' time, Musk Industry is going to have access to the smartest AI in the world, and they're also going to be manufacturing labor with the humanoid robot. So those two things together feels like the perfect place for them to just build everything they need, right? And that's a massive oversimplification. But I feel like those two things coming together could give them I don't know. Like, is that a crazy thought?
Well, the allocation of bots is going to be a very, very fascinating thing to watch real time. Because there's
what they decide to keep in house versus what they decide to sell.
Correct.
Yeah.
Correct. Because there's not going to be an infinite amount. And so if there's not an infinite amount and they have this unbelievable impact and influence on cost structure, first thing you're going to do is you're going to serve your own needs. And then you're going to figure out, like, what is the allocation system? It's going to be a wild thing to think about. Like, we can have a whole show about what are the thoughts behind how NVIDIA GPUs are allocated today. It's an interesting thing to think about. Like, how is it? It's not just check size. It's not just, there's a lot that goes on that's involved in that. So how are the allocation of bots going to be is going to be a very interesting thing to watch real time. Yeah.
So the math is going to have to be like, how am I going to make more selling these products versus the money I'm going to save using them in the factory, and or the opportunity cost of throwing up a brand new thing that I'm trying to build?
Yeah, or is the government going to get involved and say you have an anti-competitive issue, and so it's wild to think through, like, how are you going to navigate this situation? I'm sure these are things that people think about, as they're getting ready to make dinner or whatever. But it is going to be an interesting thing to think about. They're going to be under allocation for years. There's not going to be enough bots for years.
Yeah, a decade at least, I would say.
Yeah,
that's how it feels. Yeah, well into the mid 2030s. What a wild time! This is crazy. I can't believe it. I actually can't believe this is like a real discussion. Okay, but it's 1000% a real discussion, because it's like there's so many players doing it. Tesla just freaking made a deal with Samsung that basically solidifies their need for those chips that are going to go in those bots, and then some, right? And every other player is doing the same thing. NVIDIA's demand is not slowing down. Everyone and their cousin is getting into the human or robot game. So,
yeah.
And Hans, did you have anything else you wanted to throw out there for Jeff before we let him go? Jeff, any parting words or anything you wanted to hit before we wrap this?
You have to look at the visibility that Tesla and Elon has to make these multi-billion. We're talking 20 billion plus of early commitments. This isn't even the whole check size for these things, And then you see the check size that's going to NVIDIA on the infrastructure, the AI factory side. And you have to wonder what they're seeing. And you have to wonder what kind of visibility they have. And then you have to look at the peers that are in that space and what are they doing? And how many things have kind of started and stopped and never came to fruition. I think if you're following Tesla, these are gigantic moves, because the prior moves have all been their own factory development, their own, and now you're seeing major commitments to partners and these partners know that Tesla is just very serious and very capable, and there's a lot of certainty in that demand signal if it's coming from Elon and it's coming from Tesla. And I fundamentally believe this is why he got NVIDIA parts sooner. By the way, I do think he could have paid up for it. He could have paid expedite fees. Those fees could have been tied to some sort of bring up time, where if he brought it up in a certain period of time, maybe they get released. The point is that you're NVIDIA, you want those things going out, you want them reordering as quickly as possible, you want the data center going up as quickly as this flywheel. Everything comes back to this flywheel, and it looks like Elon is creating the flywheel now for the rest of the supply chain that's going to power AI forward. It's going to be silicon partnership, battery energy partnerships, everything that's needed to power. Now I'm going to be looking at are there big mineral deals that are going to be done as well. That's be an interesting thing to follow and watch.
That's such a fascinating thing. Is like I didn't click for me until now. Like Tesla's journey has gone from the Model S and the Roadster and the Model 3 somewhat struggling to get favor with suppliers because they weren't sure of their, like, are you good for this allocation long term? Versus, oh yeah, if Elon says he wants it, of course, obviously we're going to sell it to him because he's going to buy it and he's going to keep buying it forever. Like that confidence
Certainty.
That your customer, exactly. Mm-hmm. He's gone from max uncertainty to max certainty.
There's two awards that are highly coveted right now in the supply-based world. If you get an award, or if you get an award with Tesla, I'm serious. The Model Y is the number one
That's huge.
Selling vehicle model in the world, and they have a very low model count. So if you're a supplier and you get an award on that car, you are getting more volume per part number per SKU than any other business you're doing in the automobile industry. And then now take that same logic and transfer it over to GPUs. If you get a GPU order from Elon, you're either going into the XAI world, you're going into the Tesla world, you're going into the training side, you're going to the inference side. It's the best award you can possibly get is with so, and then that creates value for Tesla, and it creates negotiating leverage for Elon and his companies based on their ability to execute. It's the whole flywheel.
Same thing with Cybercab. Same thing with with Tesla Bot. If you're a supplier in those ecosystems, like even if it's the seat for the Cybercab, you're going to trip over yourself to get that.
Right, because you're entering into the robotaxi category, and who has more robotaxi business in volume than Tesla? And you're thinking about your investor base. You're thinking about how to grow the valuation of your own business. And there's this huge category emerging, and it's robotaxi. Who's entering in with the most highest volume product? They already have it today. If you look at the production rate of a robotaxi today, and where will they be with the Cybercab in the future, creates tremendous leverage for them within the supply base. Flywheel turns. By the way, suppliers get a good deal. It's a win. It is the proverbial win-win with Tesla. Win-win. Tesla's not milking anything. They're giving them certainty of demand, and they're giving them a very short network latency supply chain. So that order to cash cycle is very short, and then they can reorder again. The give on the Tesla side with suppliers is enormous. They don't have to do big check size. They don't have to do these things. They have a very good supply chain, and they have great forecast and certainty. It's not always perfect. I'm sure there's been situations where they've had to strand somebody here or there, but in general, if you're a supplier to Tesla, you have tremendous certainty in your business and you have a really, really strong performing customer on the other side of it.
Jeff, I know you got to go here in a couple minutes. Let people know where they can find you.
Yeah, I'm just on X at Jeff Lutz, and occasionally post a few comments here or there. And also, we do a couple of pods here with, with Herbert pretty regularly as well at Cyber Bulls. So yeah, having a good time talking about this. But yeah, the rest of it is back to work.
And that good work that is, especially during these times.
Thanks, guys.